Good day. My name's Terry Siggins. I'm the Global Marketing Director and EMEA Sales Leader for Brüel Kjær Vibro. And this morning I have with me Sebastien Limon, who's the Regional Head of Service in EMEA. Good day, Sebastien. How are you?
Hello, Terry. I'm doing fine. And you?
Yeah, I'm doing well, thank you.
Okay.
So today we're here to talk about the world of LNG. And just by way of an introduction, so we currently have 23 LNG trains, liquefaction trains across 6 plants worldwide, which means that we basically look after almost 20% of the worldwide production capacity. So one of our biggest customers is Nigeria LNG. With a large high performance production capacity, which includes 7 trains, Nigeria LNG serves as a benchmark to all other LNG producers. So we've been monitoring this plant since 1999, and we're currently in the process of implementing our 7th train. So Sebastien, in such a big plant, how many machines would we typically monitor? For example, on the new train 7?
Yeah, on this specific train, this train has a larger production compared to the others. And we are monitoring about 150 critical machines. Also, 750 fin fans, cooling fans, and about close to 1,000 balance of plant machines. This is quite a large train, with a high production rate.
Okay, and just a really simple question for a non-specialist. Why is it called a train?
A train, maybe due to the way the machine are aligned. I can tell you why this is named a train, but I can explain you what is a train. Is a process where we are receiving the crude gas from the different fields. It can be onshore or offshore, and the idea is to cool the gas in order to make it liquefied. Yeah, and we are using a specific process for that. Yeah, and.
Okay, thanks. So look, it sounds like an expensive process. So what's the cost in downtime if a train goes down?
Yes, since now the LNG, the hot price for LNG reached almost $8 per million of BTU. Now, if today the train 7 go down for 1 day, I think this will cost approximately 7.5 billion as a lost production. Yes.
Wow, it's a lot. What are some of the critical machines that we're monitoring?
Most of the critical machines are used for liquefaction process. And by example, the most common and the most important machine are the MR and the PR compressor. These compressors are driven by a large gas turbine, and they are used for the propane and mixed refrigerant. Yes. We have also different machines like liquid expanders. We have cryogenic pumps, which feed the tanks. We have the end flash compressor, which is used for recycling the gas. We have a lot of critical machines. Yeah, this is not an exhaustive list, but these machines are maybe the most important.
Okay, and what kind of monitoring techniques do we use to keep these machines running?
We are with our solution answering two I would say 3 main functions. One of them is the safety monitoring. We ensure that when the vibration reaches a certain level, that the machine will stop and will not create additional failure or downtime to the customer. If we can stop the machine early enough, this will avoid any collateral effect on the machinery side and also on the plant side and also on the personnel for the employee.
Okay.
Yeah.
So
this is for the safety monitoring, but beside this, we are also doing condition monitoring in order to predict when the machine will fail, and when the machine will fail, and what will be the root cause. This is what we are doing through the vibration analysis.
So it's both for safety at one end and predictive maintenance at the other end.
Maintenance, yeah. And besides this, we are also correlating the vibration data with the process data in order to monitor the performance of the machinery. We want the performance of the machinery to be optimal, and then we are monitoring some calculation based on the process data and vibration data. We have some KPIs that the rotating equipment engineer are monitoring, and we are providing such solution. Yes.
So we're also not only affecting the maintenance side, but also the productivity of the train.
Yeah, you're right. Yeah.
Okay. So what are the challenges of monitoring these types of machines?
This machine are working in a particular environment. Yeah, cryogenic temperature. That means down to minus 160 degrees Celsius. That means we need specific sensor, we need specific equipment and a specific knowledge to monitor such type of machineries. Yeah. And knowing that a downtime is very costly, then we try to minimize as much as possible the downtime for this type of industry, but for all type in general of industry, but specifically for the LNG, for the liquefaction LNG process. Yeah.
So what kind of benefits would a customer like Nigeria LNG get from this monitoring, and what would we plan to improve this in the future?
What we can learn from our history is that our system has avoided a lot of unplanned downtime due to the fact that we can detect quite early the fault, and before the failure is coming. We have set up some condition monitoring capable to perform such services for the customer.
So I guess we collect a lot of data. Yeah. What does a customer do with the data that we collect?
This is actually a long learning process because we are starting with a typical template, typical monitoring template, and we are tuning from time to time because we have a maintenance contract with Nigeria LNG, and we are studying what could be the best monitoring strategy, and we are adapting the solution to the customer. Yeah. As a condition monitoring solution. At the beginning we are applying typical template, and by thinking about the failure case and the history of the machinery, we adapt the condition monitoring to the customer machines. Yeah. To the processes also. Yeah.
Okay, so if in summary then, from what I've heard today, to begin with, we provide a safety function to make sure that nothing goes wrong with the machine. Then we collect data, which we use to perform predictive maintenance and avoid unplanned stoppages. And then finally, by using that data and learning from it, we're in a kind of continuous improvement process where we're improving productivity to make sure that we keep the machine running at peak performance.
Yeah, this is the idea. Yeah. Now we are working for Nigeria LNG for almost 23 years. We have gained so much experience with this very good relationship, and now we are capable to monitor all machines from with a high degree of expertise in the LNG process. Yeah. But today, I would say we are the right company or the right candidate to help you to monitor your machines, the LNG businesses. Yeah.
Sebastien, I think that's all we've got time for today. So thank you for sharing your experiences in LNG and particularly Nigeria LNG. Look forward to the next discussion.
Yeah, thank you, Thierry. Yeah.
Thank you. Goodbye.
Bye-bye.